Hello, my name is Peter Phelps of Phelps3D, and I'm going to do an introductory to Freecad. This is the 0.16 version, pretty much the latest at the moment. And Freecad is a parametric modeling program that's done by a community. They have a website, and I'll include the link to it inside the video description. You can download the program for free. It's fairly sophisticated, but still has some room for improvement. But the community in general is continually updating and changing it. So it could easily be in the next version within maybe a year or so. So let's get into it. Normally when you open Freecad, it will start up in the Start Workbench, which has links to the user manual, the Freecad web page, etc. inside of it. Down here, the tutorials, user manual. Now, for the most part, you bring this drop down. This is all of what's called workbenches. Most part of the time, I work in the part design, draft, and sometimes drawing if I need a 2D drawing like you would produce for patent applications. I also have I added to it the drawing dimensioning workbench so that I can easily add dimensions to parts for that. But we're going to work mostly in part today. And then we want to create a new document. So I have a blank document. And the first thing you have to understand about 3D printing or the design here is your coordinate system. The Cartesian coordinate system basically means there's an origin which is 0, and then anything up, down, out from it is a positive number or negative number depending on that 3D point. Now, on a 3D printer, most of the time, the X is your left and right, your Y is your depth, that's away from you or towards you, and your Z is your up and down. The reason to understand that is that is how all your items are going to be described in 3D space. The nice thing with Freecad is it's always got this little arrow here so you know which is which depending on the view you're in. Right now we're in axometric view. Change. See how it changes the arrow down here top. So the little arrows down at the bottom corner rotate around depending on what view you're in. A lot of times I like to work directly in axometric. So in axometric means you're in 3D view. So this is called the Views toolbar. This is your shapes toolbar or your primitives. This here is your modifiers, and we'll work from there. So we have a blank document. The shape toolbar. I like tasks combo view. See this thing, this box here? I like to work in model rather than tasks. And right now we have an unnamed document because we haven't saved this. So you have a choice of cube, cylinder, sphere, cone, torus. This one will allow you to have multiple other objects. I'll click that one. You can use a plane. A plane is not a 3D printable object. A plane is just a flat surface. So almost all objects have a default size, like this has 10 by 10. Your cubes are going to be 10 by 10 all the way around. Your cylinders 10 high. So if you click this, you have a selection of the same ones you had before, but then there's a different one that's called ellipsoid, which is an oblong sphere. Prism, where like if you wanted to make a stop sign, or you can select different numbers of edges. Wedge is something that's an angled box. A helix is only a two-dimensional object. It spins around. You'll use that mostly for threads. Spiral is again a two-dimensional object, and that would, like if you wanted to make a burner or something that was circular but spiraled in. Most of the rest of them you're not probably going to use too much, because creating a polygon, you're most likely going to just make a prism. Here you can work with a 3D object. So I'm going to close that one out. So let's just create a cube. Click on the cube. This has a 10 by 10 by 10. You click the cube itself. Ten by 10 by 10. You can change the placement, the angles, the positioning of it. Right now, the 0 by 0 by 0 is this corner of the cube right here. That corner. Now, if you want to switch back over to you can switch to View tab down here. See Data and View. You switch to the View tab. You can change a bunch of different properties of the box, like your line colors, your line widths, your shape colors, transparency. Transparency will allow you to make it partially invisible. You can change the visibility to true or false, but you can also do that by just clicking the object and pressing the spacebar. Spacebar makes it visible or invisible. And, so yeah, if you wanted to change the position, click on the little arrow thing and you can change the position just based on this X, Y, or Z, how far from the origin. If you wanted to change the angle, you can rotate it by whichever one axis has the 1. So you can change the default Z to 0 and change one of the other numbers, so you can change the angle and how it rotates. So what we're going to do is we're going to add a sphere. Now notice that the sphere, the center of the sphere was created at the origin. And the sphere's radius is 5 millimeters, which means it's 10mm in diameter. You can change the same things, position, axis, etc. Now, this is called the Boolean Tool Bar up here. So, say you select the cube, then press Control or Shift, depending on what you want to do, and click the sphere. This will allow you to make a union of the two. This one here creates a cut. This icon here does a fusion of multiple items. This one here creates a difference. So really, if all you have is two items, the difference between the union and the fusion isn't very much. I mean, it basically does the same thing. Most of the time I end up using fusion all, just out of habit. Cut. I do cut. Now, the order of the selection is important. The first object will be cut by the second object. So if I click cut, the sphere is cut out of the box. What I can do is I can click that if I want to get rid of it, and hit the delete key. That will undo what I just did. The reason you don't use Control Z to undo is it is very unpredictable. If you click Control and Z, it may make the entire part you were working on disappear entirely out of the project, rather than just taking you that step back. So unless I'm in part design in the sketch thing, it is useful to undo in the sketcher part, but it is highly unpredictable as far as the way it works when you're working in anything else. So I typically will just click on and hit delete to undo the last task I did. Okay, so then if we take the cube and the sphere and we do a fusion that combines both shapes, so they're now one part. They're no longer two separate pieces. And then if we take, I'm going to go sphere first this time, and then cube, and if we do the intersection, it keeps only the part where the two parts had in common. So that can help you make more advanced parts. The other tools in that bar don't tend to use very much. I'm going to get rid of the sphere. Okay, but you could use it to, like, if you wanted to create cross sections, and you say you want the sections to be by the axes. I'm going to say 2 sections. I'm going to say 3. And say okay. What that does is it cuts it into pieces. So it gave me basically two-dimensional boxes based on the object. That's what it does. It creates slices of objects. But I don't need those right now. And so one of the other things I'm going to do is show you fillet. If you can select the lines. Anything you highlight is called pre-selecting. It turns kind of a yellow or an orange color. So what we want to do is we want to click on this edge, hold the control key, click on this edge and then this edge. That way I can say fillet it, which is this object here. And I'm going to put in a value down here of the radius of 4. And hit OK. That fillets the edge, makes them rounded. Now, these tools, this toolbar up here, they measure different things. This one's just a straight measure, and you can click a point, another point, and that will give you the straight measure. Then you can use toggle 3D. You can clear all in this box here, and I'm going to close so I can switch over to a different type of measurement. Everything I do in 3D Freecad is pretty much millimeters. Measure degree, measure. Basically, I guess that's from one line to the next. A lot of times I don't use these to measure things. I typically use this one up here. The computer's going slow. Sorry. Now this measures in a direct line. So it takes 2 points and measures just between them. So if your points are slightly, like, say, instead I went that may not be completely accurate of a distance, because it's going kind of through the object rather than a direct line. But I prefer to use that one because it's really quick. It gives me numbers that I can read really easily. I'm just delete those. So basically just objects. That's the two ways to try to go through and measure something. Now, besides the way I told you I could manipulate an object as far as rotating it and moving it using the positions and the axes here, you can also use a free rotation device. You might actually do this on accident the first time, but if you double click an object, I have to get out of the fillet because it won't do it on the fillet for some reason. It just opens it up to be edited. But if you double click on an object, it brings up these. And this is your free rotation, free movement. You can move an item by clicking on the 4 arrows. There we go. And you can move it around based on those arrows. If you click on one of the lines, you can then rotate it by that axis. So you're basically able to do a lot more precision as far as how you want your objects placed in 3D space using this tool. Now, when you're done with it, you can either right click on the object itself and then just hit escape and it will go away, or if it's up, you want it to go away, you can right click on the object and say finish editing. So that's how to work with the free rotation movements. And I'm going to delete our cube. And so one thing I like to do is sometimes I'll make a plane. What I just did is created a virtual build bed. This allows me to visualize the space I have on my 3D printer. I just did 100 by 100 just as a way of saying, like a lot of those very small 3D printers in schools and stuff, like the printer bots or the Finas or some of them, they only have a 100 by 100 build volume. But on my personal one, I use a CTC 3D printer most of the time, and so I have a build bed, virtual build bed with that, and I also have one that has a cube that's say I took and created a cube too, and I take that on and I give it 100, 100, 100, and then what I'll do is I'll switch over to view, change the color, and I'll change the transparency to like 25. And in this case, you may not need plane. But what it does is it tells me how far my build capacity is. So I can build inside of this, although I may want to switch back and forth. You click this, it zooms to all. So basically I can build stuff, and if I want I can hide the cube, but I know how far out I can build something inside that. It helps guide me as far as if something is sticking out of the cube, then I've gone too far. So that's just some tips from what I'm doing. Now, what we're going to do as a project for this is also to work up a little small name tag. So one of the first things I'm going to do is switch from part to draft. This is something a lot of people want to do. They want to be able to do personalization of their own projects. Okay, and I'm going to switch to the top view. And actually, their box here is just about the same as my plane. So I'm going to go ahead and I'm just going to delete those for right now. Get those out of the way. Okay, so this tool here is the most important one as far as being able to do text. The ones that I use a lot here is the text one, the array, and the clone. The clone is really nice because if, say, you make a design, say you make a pendant or something, but you also want matching earrings, you can make clones of the object, and then you can use that to scale the object. So you can make it bigger, smaller, etc. So I like the clone tool. And the array tool is frequently used for anything that I have, like that has spokes, or that I want multiple copies of the same object. It's really a quick and easy way to do that. But for now, I'm going to go ahead and go into the text tool. Now, you'll notice these numbers over here will change depending on where I have my cursor, or at least they should be. Here it is going slow because of the video. I'm going to click right here. So I'm above the, okay. The string, I'm going to use my own name. And now I'm lucky. My name does not have anything that has something hanging off. If your name uses an I or a J, or you're going to have to try to use all capital letters when you put your name in, because otherwise you're going to have what I call orphan parts when you 3D print. Basically those I's, the dots at the top, unless you connect them some other way or put a backing to the letters, then you're going to have a problem because they're going to be separate pieces when you 3D print it. You'll pop off the thing and go, oh, oops. So you want to be aware of orphan parts that can happen. The same thing happens if you're trying to cut letters out of some other object. Like in my case, when I used Peter, if I took Peter and cut it out of something else, the hole in the P, the hole in the E's will both be separate orphan parts. So what I typically end up doing in those cases, if I'm doing a cut like that, I do a stencil block. I add a little block in there in order to keep it attached to the part. Okay, and I'm going to make this, let's say, 15 millimeters tall, and no tracking, doesn't matter. Now here's the tricky part, and if you don't know how to find your fonts, you're going to be in trouble. And especially if you're using a Macintosh, you have to understand what your path is to the fonts. Now in my case, it's C:\/ Windows \fonts, and I'm going to go Arial TTF and enter. Oops. Oh, I may have used the wrong slashes. Something. Where's my text string? Okay, there it is. I don't know why it's being a pain. You see here, C:\/ Windows fonts Arial TTF. 15 millimeters string is Peter. Okay, and I want to check the placement on that. 30, okay. We're actually going to want it to be up about 4 millimeters from the Y. So we're going to draw in a block later. Okay. And so what we're going to do is we're going to then take and we're going to draw a little star beside it. So click this and luckily we can change it by double clicking it and editing the nodes. Move the nodes around. And then we're going to switch back over to part. You want to click the shape string, and we're going to use the extrude tool here. And we want to create a solid. And we're going to make this 15 millimeters tall. Say OK. Do the same thing with the D wire star. Solid. Okay. And so, if you don't like the grid, you can switch back over to draft, and you can go draft, utilities, toggle grid. Now, you're supposed to be able to press the G and the R at the same time and get it to go away, but I have a hard time doing that. Back to part. And what we're going to do is we can switch to the 3D view again. So right now we're looking at it from the top. And so there you can actually see that it's a 3D object. We're going to create a cube. I'm going to change the cube so that it is 15 millimeters tall, same as the letters. But we're going to make the width 4.25. That should just barely be touching all the letters, and hopefully the star. We'll have to check in a bit. But then we're going to move that cube back. So right now, what you're seeing here, okay, this, you went this way, that's your Y, this way is your X, Z is the up and down. Alright, so what we need to do is move the cube in a negative number towards where the star is. So if you click in here, if you have a scroll wheel, it makes it really easy. You can just sit here and roll it back. We're going to stick it out a little bit further than it. But if you don't have that, then you just gotta manipulate. You can use the arrow keys too in here. If you up and down when you clicked into the box, if you up and down, you'll also move it less or more. Okay, and so now that we've got it there, we can adjust the length. And again, if you click in here, you can just use your scroll wheel or the up and down and make it longer. Once you've got it to where you think it looks good, check again. You want to make sure that you've got enough of it cut on. Now I don't think it does here on the star. Now you can either move the star down or the block up more, or make the block wider, depending on what you want to do. I'm going to move the star down a little bit by changing its place and position from 0, 0. I'm going to change the Y position. Because I think it's touching enough for the letters. It's just not touching enough for the star. And that might, just so that they're connected. because we're going to combine them all a bit. Now, one of the things I'm going to do, come on, I want to click, now, one of the things I'd like to do when I set up Freecad is I change the navigation style to touchpad navigation. What this allows me to do is if I want, I can click in here, I can press the Alt key, click in here, and rotate my view. This is rotating the view, not the actual object. We're just rotating the view of it. And then I'm going to click this one, press Control, click this one, and I'm going to use a chamfer on the block. So I have just those two edges selected. And I'm going to go, let's see, you don't want to go larger or the same as your width on an object. You always want to make sure it's a little bit smaller than that. So we have a 4.25 wide part, right? I'm going to make it 3. What happens is, okay, the chamfer has to, or the fillet, this works on both of them, has to be slightly smaller than the actual project itself, part. So, okay, I'm going to click OK. And so, then I'll return us back to 3D view. And what you want to do is you want to, okay, there's two differences in 3D printers that I've noticed when I do things. If I don't combine everything, fuse them into one part, what happens is that the printer will end up, for like MakerBot printers, anything that's based on a MakerBot printer, I found that it will treat every overlapping part as a difference when it 3D prints. So, let me see if I can find the pictures. So here, this is a fusion part. The parts are fused. This cross works out just fine, right? But if you don't, you don't 3D print, make a fusion, see how the box is gone, where it's met each other? That's called a non-fused part. Also, another note to talk about is, okay, if you don't mind your fonts, you need to make sure that your fonts are kind of thick enough because of what's called minimum wall thickness. The one font was in Arial. This font here is, I believe, Times New Roman, and you notice how it's missing parts. If your 3D printer's nozzle is 0.4 millimeters, then your minimum wall thickness is that size. If you go below that or get too close to that minimum, the slicer program itself will just ignore anything that's underneath that, that's smaller than that. And so parts that disappear are usually because of that issue, that you've gone too small. because you're not meeting the minimum wall thickness. Okay, so that's now. It's weird. I have some RepRap 3D printers too, and they don't really care as much about this being all fused together. But a part that's set up and fused together will always work still on the RepRaps, as long as it's a 3D printable part, but not the other way around. If you do not fuse this when you're designing it in Freecad, it will treat every overlap as a difference. It will remove that material. I don't know why, but that is the case. So I just click the top one, shift and click the bottom one. Shift will allow you to select multiple items, while control is just one at a time. And then we're going to click the fuse multiple items. Okay. Then we're going to file save. My main play. So I've done this a few times. I'm changing the name of it. Okay. I'm going to go back to where I'm doing this. Click on the object, fusion, go file, export, and then this is you want to make sure that your saved file type as is the STL mesh. And then I'm going to call it my name plate again. Then I close Freecad. And I'll open up Netfab Basic. Now I suggest always running your projects through Netfab Basic to check to make sure that they're 3D printable. Not Freecad doesn't always make perfect parts. Simple parts may come out just fine, but sometimes you'll find other parts just don't want to work the way you want. Go ahead and just go to mine. And we want the STL file. I'm going to click STL. Just open. So there's not a triangle over here with it's a big red triangle with white, and it has a big exclamation point, which usually means that there's a problem with the file. Since that's not there, we're probably good to go. We can load this into our 3D printer slicer program like Makerware or Slicer or whatever, Cura, whatever you use, and you should be able to print this out fine. Alright, thank you. And that's my first lesson. I hope to do more to help you understand how to use Freecad, how to get in and work with it. So, have a good day. Thanks.